What is the difference between instantaneous and average power in AC circuits? Imagine you're watching a roller coaster at the peak of its climb. The energy at that exact moment is different from the overall energy it uses during the ride. In electrical engineering, especially when dealing with alternating current circuits, understanding how power behaves at specific moments versus over time is essential. Today, we're going to explore the difference between instantaneous power and average power in AC circuits. In AC circuits, instantaneous power is the power value at any single point in time. It is calculated by multiplying the voltage and current at that exact moment. Since both voltage and current in AC are sinusoidal, they change continuously and can be positive or negative. This means the instantaneous power can also be positive, indicating energy flowing to the load, or negative, showing energy returning to the source. The formula for instantaneous power is simply the voltage at that moment times the current at that moment. Because of the sinusoidal nature, the instantaneous power fluctuates rapidly, often at twice the frequency of the supply voltage and current. On the other hand, average power, also known as real or active power, looks at the overall energy transferred over a full cycle of the AC waveform. It is the average value of the instantaneous power over time. This is the power that actually does work, like lighting a bulb or turning a motor. To find average power, engineers use the root mean square values of voltage and current, along with the cosine of the phase difference between them. This phase difference, called the power factor angle, affects how much of the total power is actually used for work. The formula for average power is the RMS voltage times the RMS current times the cosine of the phase angle. The key difference is that instantaneous power shows the power at each moment, including peaks and valleys, and can even be negative. It reflects the real-time flow of energy, including energy stored temporarily in reactive components like inductors and capacitors. Average power, however, gives a steady, positive value that represents the net energy delivered to the load over time. It helps in understanding how much energy is actually consumed or used for work. Knowing the difference is important in circuit analysis. Instantaneous power helps engineers analyze transient behaviors, peak power demands, and power quality issues. Meanwhile, average power is used for sizing equipment, calculating energy costs, and designing efficient systems. Reactive power, which oscillates back and forth without doing real work, is managed separately to improve overall power delivery. So, in simple terms, instantaneous power tells you what's happening at any single moment in an AC circuit, while average power sums up the total energy delivered over time. Both are essential for understanding and designing electrical systems that are safe, efficient, and reliable.